Hello AAF kids. Sorry to desert you this week, but I'm going to spend this time with my daughter and her brand new baby boy, Matthew Dean. I will make videos for you each during the week, and you will be fine, I promise. We're going to start this Unit 9, which is Conic sections, which I like a lot. I enjoy this unit because it kind of brings together a lot of concepts from previous units that you have to put together in kind of a unique way. For instance, most of our units have dealt with functions, right? That's the name of this course after all. AAF stands for Analysis and Applications of Functions. So we have been dealing with different functions, their characteristics, their properties, their graphs, their behavior, their transformations, and now we're going to deal with some things that aren't necessarily functions, but we're still going to see if we can take our prior knowledge and apply it in this non-function world. So for instance, parabolas. You've been dealing, way back in, what was that, Unit 4? 3 or 4? I can't remember now. Parabolic functions. Well, I've kind of hidden some information from you about parabolas. Not all of them are functions. And you know the parabolas very well, I hope, on the XY Cartesian plane. But I don't have to create parabolas from, just thinking about it algebraically. You can think about it geometrically. For instance, if you take two cones, and I don't know who thought of first doing this, but they did, take two cones and invert them on one another, right? So that they meet at the vertices here, and take a plane, not an airplane, right? A geometric plane that is really infinite in all directions but has no width, and pass it through these inverted cones such that it misses the first cone, only passes through the second cone, and you've tilted the plane enough so that the bottom exits through the base of the cone, right? That's how you create a parabolic shape, right? The ends are free, they're not bound. Right? And of course you can see you could tilt this plane more and more dramatically to make the parabola change shape. If you tilt this plane far enough such that it passes through both sides, it doesn't go out of the bottom or the base, then your figure, right, the slice is closed, and if you're parallel to the base, you'll create a circle, which of course is not a function. And a circle has a radius as you radiate from the center of the cone out to where the plane hits the quote-unquote side, right? A cone doesn't really have sides, but you get it. And of course, if you move this plane up and down, you'll get a bigger and smaller circle with the radius either bigger or smaller until you get right here. If you passed right through here, you would get what we call a degenerate circle, which is just a point. Right? That's kind of funny to think of a point as a circle with a radius of 0. It's kind of boring. We don't really talk about it that much. We call it a point. If you tilt the plane such that the one side of the plane doesn't come through the base, and you still have a closed figure, but it's tilted such that the radius isn't constant in all directions, that's called an ellipse. That's what we're going to start with. We're actually going to start this unit with circles, and then we're going to go to ellipses. And after all, circles are just a special case of ellipse. So we're going to go to the broader case second. Then we're going to retouch parabolas. And let me tell you that most often on this unit test, the kids miss the most points on parabolas because they're kind of overconfident, right? They're like, parabolas, I've been doing those since Algebra 1, I get it. But, again, there's a lot of information that I've hidden from you about parabolas. So be careful. Lastly, we're going to touch on hyperbolas. And a hyperbola still has the same inverted cones and a plane, but a plane that passes through both cones and exits out the base of both cones. So the figures are not connected. It's not continuous, right? Because they're the space between cone 1 and cone 2, right? There's this hyperbolic space, if you will. And both of the ends are free to go on forever and ever and ever. Okay, so we're going to start talking about the simplest case, or the simplest and most familiar, which is your circle. So if you would get out your notes, okay, the general equation for conic sections. Now, I'm going to write this big, long, hairy equation, and you copy it down, and please do use capital letters. Capital letters. Whoa, right? Notice there's an x squared term. There is a term where x and y are multiplied. There is a y squared term. There is an x to the first, a y to the first, and f is a constant. Now I want you to recall way back in the linear unit. If you recall, lines, the standard form of a line was capital AX plus capital BY plus C is equal to 0. Can you kind of sort of see that right here? This is a diagonal line right here. There are some that will say a diagonal line is a conic section, and I'll show you why. I don't particularly. Just like I don't consider a point a conic section, some will call it a degenerate circle. A linear function, if I go back here and talk about this plane from the hyperbola, if you tilt this plane enough such that it doesn't intersect the cone at all but just lies against the side like this, there's your diagonal line. That's a degenerate hyperbola. I don't like the name degenerate, so I just say point and line. But I wanted to, right, I told you that that standard form of a line, this is where it comes from. It comes from the conic section. Kind of crazy, right? So what degree is this equation? And if you remember, this is from the very first days of this course, right? Way back, right, where you were reading some pages in your textbook. The degree is the highest number of highest exponent you see on any variables. So this term is squared. Technically this term, the b term, is squared too, because each one of these is a power of 1, and 1 plus 1 is 2. This term has degree 2, this is degree 1, this is degree 1, and this is degree 0, right? Technically has an x to the 0 and a y to the 0. So this is a second degree. And a second degree is quadratic. But this equation for conic sections is not a quadratic function, but it is a quadratic relation, and yes, you need that vocabulary. No. Not with both x squared and y squared. Right? If you have x squared and y squared, you do not have a function, because your y squared term means that for a domain you're going to have two range values. Right? Can't have that. So as long as your general equation for conic section has both the x squared and y squared term there, in other words their coefficients aren't 0, you don't have a function. If a, b, and c were 0, you would have a linear function. Yes. But assuming that the coefficients aren't 0, no, you don't have a function. However, just like our functions, the coefficients of the x and y terms, the one on the most powerful, right? Think about your rational functions, how the highest power controlled the n behavior, right? Your x squared term and its coefficient and the y squared term and its coefficient have the most power over the shape of your conic section. For us in AAF, we are not going to have that xy term. B will always be 0. B is what we call a rotational term. Right? The rotational term will take your shapes and rotate them from a horizontal or vertical orientation and make it like a diagonal rotation. So for example, an ellipse, right? We are only going to have ellipses that are oriented horizontally or vertically. We are not going to have any ellipses that are diagonal, because that would take a B term that would rotate off the horizontal or vertical. So we are not going to have this term, because for us B will always be 0. And I didn't even have to mention B to you, but I didn't want to give you the general equation and go ax squared plus cy squared and have somebody go, hey, what happened to B? Right? So I'm telling you what happened to B. B for us is 0, therefore the xy term has disappeared. So we're going to do example 1, where A and C are the same number and that number is 1. I am going to make D and E equal to 0, so you won't see the linear terms. And I'm going to make F negative 25. So example 1 takes the general equation for conic sections and turns it into x squared plus y squared minus 25 is equal to 0. So let's look at that example. Right? The coefficient of x squared is 1. The coefficient of y squared is 1. D is the same as E, and both of them equal 0. F is negative 25. What kind of conic section do I have? Remember, you've got choices. You have a circle, an ellipse, parabola, or hyperbola. Hopefully from geometry you remember that if you have an x squared plus y squared is equal to a constant, that's a circle. And this is a circle that's very nice because its radius is an integer. Right? This is the equation of a circle, not our unit circle. Our unit circle had a radius of what? 1. Yes. This is a circle whose center is at the origin, but whose radius is 5. The standard or graphing form of a circle looks like this. So copy that down while I answer my text. Hold on. I need to find out if I have sorry, sour cream. Mr. Getz and I are putting our grocery list together, so I have to tell him that our sour cream situation is good. Okay, so the general form has all those capital letters in it. This is called the standard form. I like to refer to it as the graphing form because this is graph friendly. Notice I still do have x, which is squared. I still do have y, which is squared. I also have the radius squared, but I have this funny h and k. O shift. This is a shift of the x. O shift. This is a shift of the y. Remember, our unit circle had a center at 0, 0. So does this circle, and that's because h and k are 0. When I think of, I don't know where h and k came from. I have no explanation for why h and k were the variable, or not the variables, but the letters used to represent the x shift and the y shift. Yes, I like to think to myself, oh shift. Oh shift. I like to think x minus the x coordinate of the center and y minus the y coordinate of the center. And then of course the number on the the number on the other side is the radius squared. So over here is my circle. So please make an axis. when you're graphing a circle for me, there must be the center labeled, right? And I want you to look at this equation. Our equation in graphing form looks like this. Our center is 0, 0, and our radius is 5. Okay. When you're graphing and labeling a circle for me, I'm going to be very particular with you. From the center, I want you to radiate straight up and label. Y coordinate of the center, comma, shift. Straight down. I'm sorry, X coordinate. X coordinate of the center, comma, shift. Right? 5 units up, 5 units down. Y coordinate of the center, shift the X. Radiate to the left. Y coordinate of the center, O, shift. Shift to the left. So 5 points need to be labeled. That should remind you of our trig graphs, right? You need the center, and I need to see the ends of 4 radii. The radius straight up, straight down, the radius straight right, and straight left. Okay. So sketch and label this circle. Notice it's already in graphing form. This is not in general form. I gave it to you in standard or graphing form. So you need to say to yourself, self, this is x minus plus y minus is equal to something squared. So what do we have here? The x coordinate of the center is 3. The y coordinate of the center is not 4. What is it? The radius is not 49, it's an integer. So, center 3, negative 4, radius 7. So over on the axes, I want you to go 3 and down 4, label the center. Then you're going to radiate for me, and you're going to radiate 7 units up, 7 units down, 7 units to the right, 7 units to the left. So think about where that lands you. If you go 7 units to the right, the y coordinate does not change. You take the 3 and you add 7. O, shift. So you get 10, negative 4. Then you take the center and you subtract 7 to go left. And you get negative 4, comma, negative 4. Then you operate on the y. You go up 7 units, so an up is in a y direction, and you get 3, 3. Then you go down 7 units and you get 3, negative 11. I will not judge how you draw your circle. Oh my gosh, that's the worst. Right? Maybe you shouldn't do it like that bad. It's a little bit better. Okay? Center, straight up, straight down, straight right, straight left. Okay? And it's all shifts. From the center, shift up, shift down, shift right, shift left. Start with the center. Notice that the two vertical points have the same x coordinate as the center, and the two right-left points have the same y coordinate as the center. Maybe pause the video and you try and graph and label this one and see if you get full credit. Okay? Alright, so let's assume that you paused and tried this yourself. So hopefully graph the center, 0, negative 5, and your radius is 3. So 0, negative 5, shift up 3, add 3 to the y coordinate, shift down 3, subtract 3 from the y coordinate, go right 3, add 3 to the x coordinate, go left 3, subtract 3 from the x coordinate, and sketch. Oh, this is harder than it looks, my friends. My goodness. 5 points. Tiger, gotta have my x and y, right? Check out this next one. Ready for Algebra 1 to come back at you? Oh snap. Look at this inequality. Now I want you to think about way back in Algebra 1, someone taught you how to graph the line 2x plus 5. Then they said, what happens if I ask you about y is less than 2x plus 5? Which range values are equal to 2 times the x coordinate plus 5 versus what range values are all smaller than 2 times the x coordinate plus 5? Take that same thinking here. Let's not worry about the inequality first. Let's just talk about this is a circle. X is squared, y is squared, and I have a radius squared, and the radius is an integer, right? The center is not 3, it's negative 3, comma 2, and the radius is 5. So let's not freak out. Negative 3, 2, and let's label negative 3, 2. Let's go 5 units to the right, 5 units to the left, 5 units up, and 5 units down. Where do I land? Negative 3 plus 5, negative 3 minus 5, 2 plus 5, and 2 minus 5. Now, I'm going to sketch the circumference. Here's the circumference of the circle. Think. The circumference. is the set of all points that is a constant distance from the center. Where's the center? Every x and y that you add 3 and square to, subtract 2 from the y coordinate and square, has to lie not on the circle. Where does it have to lie? All the points have to be smaller than the radius. How? What do you think you graph if you want all the points not on the circle but smaller than the radius? That's right. Inside. How do you do that? Your circumference needs to be dashed, and you shade inside the circle, right? Just like you did with lines. You just shaded, your line wasn't enclosed, so you would have to shade above or below it, right? With a circle, you have to shade inside or outside. What in the equation would make me graph outside instead of inside? Exactly, greater. How about, what would I do, what would the equation say if I wanted the circumference to be solid instead of dashed? Exactly right. If instead of less than, it was less than or equal to, my circumference would be solid. Since it was less than or equal to, not only should my circumference be dashed, right? So let me go back to the original. Not only should my circumference be dashed, but what should be true about these points? They should be open circles, right? Not the center. The center is not a point on the circumference. It's a characteristic of the circle. Right? Okay. What do you do if the equation I gave you is not in graphing form? First thing you do is cry, right? Because this is a dagger. So, this is now example, what, 4 or 5? A is 1, the coefficient of x squared is 1, the coefficient of y squared is 1, but this time I have a d that is -10 and e that is +4, and the constant is 13. So I say to myself, oh, I can't, if I want to graph it, I need to graph it, and let's say I want to graph and label. I can't see the center. I don't know what the radius is. Hint, it's not 13. I need graphing form, and graphing form has two, count them, 2 groups of stuff squared, and then it has an equal sign with a radius squared. See what you want and make it happen. I have algebra that can help me. I'm going to take the x things and y things and complete the square twice. This is my recipe. Some people like to work all on the left side with their algebra. I like to get my constant to the right side. Then I use the commutative property and I group the x and y terms. Then I factor out any coefficients. Right now my coefficients are just one of my squared groups. Then I complete the square, and I cannot forget when I complete the square that at this step I am changing the equation, right? Step 1 I didn't change, I just added, right? I just subtracted 13 from both sides. That doesn't change. Associative property and commutative property don't change. Factoring doesn't change, but any values. But when I complete the square, I am changing the values of one side of the equation. I have to change it by the same amount. So I didn't change anything. I just this is the exact same equation, and I just gave myself some room over here to work. So let's see what we have here. I'm going to do step 1 and 2 together. I'm going to group my x terms, and I'm going to group my y terms, and I'm going to get my 13 over to the other side. Since the coefficient of x squared and y squared is just 1, I don't have anything, right? I'm done with this step, and I'm done with this step. So now I'm going to complete the square. And to complete the square, I'm going to add something to each parenthesis group. So, see if you can follow this as well, right? This is one of the reasons why I practiced this in our parabolic, right? Our unit on parabolas was so, right? I knew you were going to use it here, and you were going to need to be fast. I'm not going to go through this. You have notes back on complete the square. You need to, once you have a coefficient of 1 here, you need to divide the middle term by 2. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Add to the right side as well. Positive 4 divided by 2, and then is positive 2 squared is a 4. Add to the right side. Now when I'm completing the square, the whole reason to complete the square was to get 2 groups that are squared. When I have now birthed the perfect square trinomial, this is x minus 5 squared, and this is y plus 2 squared. Guess what negative 13 plus 25 plus 4 is? Well, 25 and 4 is 29. 29 and a negative 13 is 16. Isn't that nice, right? This is a math book, so that turns out real nice, right? Because this is actually x minus 5 squared plus y plus 2 squared is equal to 4 squared. What's my center? And what's my radius? Can you graph and label this? Five, negative 2. Up 4, down 4, right 4, left 4. This is an equal sign, so I just have a solid terrible. Forget it though. 5 comma plus 4, 5 comma minus 4, 5 plus 4, and 5 minus 4. And again, it is a solid circle. No shading because of the equal sign. Why don't you go ahead and pause the video and try this. Alright, I assume you paused the video. Notice I don't have to complete the square for the x stuff, but I do the y stuff, right? Negative 14 divided by 2 is negative 7. Negative 7 squared is 49. So I get x minus 0 squared plus y minus 7 squared is equal to is equal to -1, there is no circle possible. You can't have a negative radius. Don't talking to me about negative space and black holes and blah 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 blah, right? You can't have a circle with a radius of -1. That does not make any sense. So there was no circle from this equation. There was no graph possible. All right, let's go. Let's do another objective. So far, right, you have been able to, right, given graphing form, you can graph and label. Right, that's objective 1. Objective 2, given standard form, you can graph and label. But standard form means you have to complete the square to get to graphing form before you can graph and label. Here's objective 3. Objective 3, given information about a circle, write the equation. Right? So, given information, sometimes I might list it out, but sometimes it might be a drawing. For instance, what if I give you that the center is at -4, 6? If I haven't drawn it for you, I want you to draw it. -4, 6. The next piece of information I give you is a point on the circumference. So notice from my center, I was able to fill in x minus -4, right, the x coordinate of the center, y minus 6, the y coordinate of the center. But I don't have an x, a y, or an r. How can I do this? Right? You have 3 unknowns and you need r. Well, what's true though? You have an x and you have a y. How about plugging it in and figuring out what r is, right? Since this point is on the circumference, you have to be able to plug in the x for the x and the y for the y and land on the circle, which means you will radiate from the circle out and of course square that. So what do we have here? 2 squared plus -9 squared is equal to the radius squared. So that's 4 plus 81, which equals 85. So r squared, so the equation must be x plus 4 squared plus y minus 6 squared is equal to 85. Now remember, 85 is not the radius. 85 is the radius what? Squared. So the radius isn't an integer, right? What is the radius? This means the radius is, right, plus and minus the square root of 85, right? You go up root 85, down root 85, right root 85, left root 85. And what is the square root of 85? Is it bigger than 6? Is it bigger than 7? Is it bigger than 8? Is it bigger than 9? Is it bigger than 10? No, it's like 9-ish, right? Here's another way to think of this problem. check out the point -2, -3. That's on the circle, right? So that distance is what? The distance from the center to out to the circumference. What do you call that distance? That's the radius, right? So, what does the circle look like? Now, I don't have enough room, right? But this, remember, this radius stays constant, so it's a circle. Whoa, wow. That's so terrible. You get it, right? That's so bad. Anyway, this point is on the circle. Well, I wonder how far that is. It's a diagonal line. How can you tell what is this distance? What is the radius as a distance between 2 points? It's just that the 2 points have to be one at the center and one on the circumference. Isn't that just the distance formula? Hello. How far did you change in the x direction? Right? From the point on the circle, how far left did you go? How far up did you go? Well, you went from -2, right? How many steps did you go? That's x1 minus x2. Which is -2. What is your change in y? Your change in y is y2 minus, right, y1. What is that? -3 minus 6. And remember, that is the distance formula with what? Whoops, I forgot to square these. Square that one. The square root. The distance formula is how you find the length of a radius. And this is just the change in x squared. This is the change in y squared. Add them together. They're the legs of a right triangle, right? If you add the squares of the legs of a right triangle, it will equal the square of the hypotenuse. And of course, if you just want the hypotenuse by itself, you have to take the square root. The radius of this circle is a hypotenuse, just like we did for our unit circle, right? Just for our unit circle, this x value was a cosine and y was a sine, right? It all comes together. Anyway, of course, you would get out of, what would you get out of this? You would get the square root of 85, which is your radius, and you know that your radius, you have to go to label this. You would do what? You would go out here, and you would say this is -4 plus root 85, comma 6. And this point would be -4 minus 9-ish, comma 6. The point at the top would be -4, comma 6 plus the radius. And the point all the way down here would be -4 minus, right? The plus minus square root of 85, comma, whoops, sorry, -4, comma, I was doing the x-coordinate, wasn't I? -4, and then I have to take the y-coordinate and shift. Right? Cool beans. Alright, your homework is the handouts that the substitute has for you. So please finish those. I am going to be asking the substitute to keep track of your homework, so please make sure on the roster that I've left for the substitute that you are checked for having your homework. And I will be, oops, I forgot that I wrote that. Right. The radius squared of a circle is just how far you go from the center in the x, how far you go from the center in the y, square them and add them together. Right. I will be back in a video tomorrow.